Determine the empirical and molecular formula of each of the following substances. Part A. Ibuprofen, a headache remedy, contains 75.69% carbon, 8.80% hydrogen, and 15.51% oxygen by mass, and has a molar mass of 206 grams per mole. Now we're going to pretend that we have about 100 grams of sample. We can do this because every sample is going to have the same percent by mass as any other sample, as long as we're following the law of definite proportions. So we will pretend that you have 100 grams of ibuprofen. Then 75.69 grams of our sample is going to be carbon, 8.80 grams of hydrogen in our sample, and 15.51 grams of oxygen will be in our sample. Now we're going to convert all of these grams into moles, because moles are our best friend. And moles will help us figure out the ratio of the carbon atoms and the hydrogen atoms and the oxygen atoms in our sample. So I'm going to divide my grams of carbon by the molar mass of carbon, 12.01 grams of carbon per mole. And I'm going to divide the hydrogen by 1.008 grams of hydrogen per mole. And I'm going to divide the oxygen by 16.00 grams of oxygen per mole. Now I'm going to grab my calculator and I'm going to figure out how many moles are in each of these gram amounts. So for carbon, let's see, 75.69 divided by 12.01, that's going to be about 6.302 moles of carbon. Next, we have hydrogen. That's 8.80 divided by 1.008. It's going to be 8.73. I actually only need 3 sig figs, so 8.73 moles of hydrogen. Perfect. Now I'll do 15.51 divided by 16. That's 0.9694-ish. moles of oxygen. And I'm just going to go back and make sure I label everything correctly, as you should always. Now, I'm going to need to divide each of these pieces by the smallest number of moles. My goal here, ladies and gentlemen, is to figure out my ratio of moles so we can figure out the ratios of atoms in our formula. So, my smallest one is going to be that oxygen. That 0.9694 moles of oxygen. So I will divide my carbons by 0.9694 moles of oxygen. I'm going to divide my hydrogens and oxygens too, but I'm going to go ahead and do that math. Let's see. 6.302 divided by 0.9694, that's going to give me about 6.5. Now you don't have to be specific on sig figs for this bit. Okay, this is going to be about, let's see, 8.73 divided by 0.9694. It's going to be about 9. That's a nice solid whole number. And then obviously, if you divide a number by itself, you're going to get 1. So my ratio here is unfortunately not a whole number ratio. Lucky for us, that 6.5 is actually really easy to change into a whole number. I'm just going to multiply it by 2. But if I do that, I'm going to mess up my ratio. So I need to double all of my numbers. Now again, I chose to double because if I double something that's a half, that will change into a whole number. So 6.5 times 2, that's going to be about 13. 9 times 2, that'll be 18, and 1 times 2 will be 2. Okay, let's just write that down. So C will have 13 C's. Let's see, we will have 9 times 2 H's, that's 18, and oxygen times 2. There we go. Perfect. So this guy is our empirical formula. We have our smallest whole number ratio. The 6.5 would have been okay if you weren't looking for whole numbers, but we're always looking for whole numbers of atoms because really we're not going to have 6.5 carbons. So we're always looking for the smallest whole number ratio. And this is the definition of an empirical formula. Awesome. That's half our question. Now, we need to check and see if this smallest number of atoms for our formula is going to be okay for our molecular formula as well. So we're going to check the molar mass that was given to us earlier in the problem and see if the molar mass of our empirical formula will match that formula. Let's see. I'm going to have to look up what that molar mass was earlier because my memory is not perfect. Let's go see. 206 grams per mole. So we need to check if this formula has 206 grams per mole. What we're going to do is our normal molar mass calculations. We are going to have to do carbon first. So we'll do 13 carbons times the molar mass of carbon, 12.01. Let's see, 18 hydrogens times the molar mass of hydrogen, 1.008. And the molar mass of oxygen times 2, so that's 2 times 16. Add all those guys up in your calculator. Totally fine to just put those numbers in just like that. It will do PEMDAS for you, and all of your numbers will work out perfectly. Let's see. If I punch this in my calculator, I'm going to get 206 with a little bit of change. So that will round to 206. This is perfect because that means our empirical formula is also our molecular formula. So for this problem, C13H18O2 is also our molecular formula. And that is how you find the empirical and molecular formulas from the percents of elements.